Life. A delicate flicker in the vast expanse of the cosmos. It exists on a knife's edge, a constant negotiation, between order and chaos, between vibrant existence and stillness. This balance is fragile yet persistent. It is a marvel that it continues day after day. This quiet miracle unfolds all around us and within us. The grand drama of survival is not played out on vast battlefields. Its most fundamental stage is almost invisibly small. It is the world of the single cell, a microscopic universe teeming with activity. Here the essential struggle for life occurs. Each cell is a tiny hero in this ongoing story. Imagine a world bustling with purpose yet hidden from our eyes. This is the realm of the cell, the basic unit of all known living things, from the smallest bacterium to the largest blue whale. Every living organism is composed of these tiny engines. They are the architects and builders of life itself. Their quiet work underpins everything we see. The sheer complexity packed into such a minuscule space is breathtaking. Step inside a single cell. It is a bustling metropolis, a city that never sleeps. Thousands of different tasks are happening all at once. Proteins are being built like tiny construction workers. Messages are being sent and received. Waste products are being processed and exported. This miniature city has its own transport systems. Molecules are ferried from one location to another. It has its own defense mechanisms protecting it from invaders. It has repair crews, constantly mending any damage. All these operations must be coordinated with incredible precision. If one part fails, the entire city can be in jeopardy. The cell is a marvel of biological engineering, refined over billions of years. All this frantic activity requires one crucial thing: energy. Just like our own cities need power to function, the cell's machinery, its transport, its communication, none of it can happen without a constant supply of energy. This demand is relentless. It never stops as long as the cell is alive. It is the fuel that keeps the city running, the very essence of its vitality. Without energy, there is only stillness. Nature has a fundamental tendency. It moves towards disorder, towards simplicity. Scientists call this entropy. Imagine a slinky toy at the top of an escalator. It wants to tumble down step by step. It wants to reach a state of rest at the bottom. This is entropy in action. The universe itself tends towards this state of greater disarray. Living cells, however, do something quite extraordinary. They defy this downward pull. They build complex structures. They maintain intricate organization. They are like someone trying to carry that slinky up the down escalator. This requires constant effort. This upward journey, against the natural flow of entropy, is what defines life. It is a constant battle. A struggle to maintain order in a universe that favors chaos. To stay alive, a cell must continuously work. This fight against entropy is not easy. It is the cost of being alive. Section 4, ATP, the universal coin of life's realm. What is this magical energy that cells use? How is it stored and transported within that bustling city? The answer lies in a remarkable molecule. It is called adenosine triphosphate, or for simplicity, ATP. Think of ATP as the universal energy currency of the cell. It is like a tiny rechargeable battery, or a coin that every part of the cell accepts as payment for work. ATP is a relatively small molecule, but it packs a powerful punch. It stores energy in its chemical bonds, specifically in the bonds that hold its three phosphate groups together. When a cell needs energy for a task, like building a protein, it spends an ATP molecule. One phosphate group is broken off. This releases a burst of usable energy. It is an elegant and efficient system. Once ATP has released its energy, it becomes ADP, adenosine diphosphate, with only two phosphate groups. It is like a discharged battery, but the cell does not discard it. Instead, it recharges it, using energy obtained from food or sunlight. This ATP-ADP cycle is fundamental to all known life. Section 5. Echoes of the dawn, life's first ingenious sparks. Let us journey back in time, billions of years ago, to a young Earth, very different from today. The air was thin, perhaps filled with different gases. The oceans were a chemical soup. It was in this primordial environment that life first flickered into existence. The first cells, tiny and fragile, faced immense challenges, not least among them, how to obtain energy, how to fuel their nascent lives. These earliest cells were pioneers. They did not have the sophisticated machinery of modern cells. They likely relied on simpler energy sources. Perhaps they harnessed geochemical energy from minerals reacting in deep-sea vents. Or maybe they utilized simple organic molecules, abundant in the early oceans. These first life forms were incredibly resourceful, finding ways to power their basic functions. The development of a molecule like ATP was a major breakthrough. It provided a reliable, manageable way to handle energy. The evolution of ATP, or a similar energy currency, was crucial. It allowed cells to become more complex. Section 6. Harnessing the Sun, the Green Revolution, and Inner Powerhouses. A truly revolutionary innovation occurred early in life's history. Some cells developed an astonishing new skill. They learned to capture energy directly from sunlight. This process is called photosynthesis. It was a game changer for life on Earth. Suddenly, a vast, untapped energy source became available: the sun's abundant light. These pioneering cells, the ancestors of modern plants and algae, became self-sufficient food producers. Imagine tiny factories, converting light into chemical energy. This is what photosynthetic cells do. They use pigments, like chlorophyll, to absorb sunlight. This energy is then used to build sugar molecules, from simple ingredients like carbon dioxide and water. These sugars store the sun's energy in their chemical bonds, and, as a remarkable byproduct, photosynthesis releases oxygen. This gradually changed Earth's atmosphere, paving the way for new forms of life. Another pivotal moment in cellular evolution was the rise of mitochondria. These are often called the powerhouses of the cell. Mitochondria are specialist organelles. They are incredibly efficient at extracting energy from food molecules. This partnership was so successful, it became a permanent feature of most complex cells. Section 7. The Grand Tapestry, from Microbes to Majesty. These cellular innovations, ATP, photosynthesis, mitochondria, were not just small improvements. They were transformative leaps. They provided the energy needed for life to become more complex, more diverse, more spectacular. The ability to efficiently harness and manage energy. This fueled the incredible journey of evolution, from simple single-celled organisms to the vast array of multicellular life that populates our planet. Think of the energy required for a plant to grow tall, or for an animal to move, to hunt, to think. All of this is powered by the same fundamental cellular processes, the ATP cycle humming away, mitochondria diligently working. In plants, chloroplasts capturing sunlight. These microscopic engines drive the macroscopic world. They are the hidden architects of forests, coral reefs, and savannas. They power every creature, great and small. The story of ATP and cellular energy is a story of interconnectedness. All life on Earth shares this common heritage, the same molecular currency, the same fundamental ways of processing energy.